Why organizations often struggle with both shadow data and inaccurate data classification? And how does this Optify DDC address these challenges to provide a reliable visibility into sensitive data across the enterprise?
So shadow data is, yes, it is one of the biggest challenges organizations face today because a large part of this sensitive data, it often exists outside the officially managed systems. It could be sitting in some shared folder or in any employee's individual laptops, any archived repositories or any collaborative platforms. So the problem is that security and compliance teams can only protect what they know or what that exists. If sensitive data is hidden in these unmanaged or say poorly governed or inaccessible locations, then it creates a lot of blind spots that increase the risk of data breaches. And as a, subsequently it calls for compliance violations as well. So this is where I think Optify DDC really helps, rather than relying solely on the asset inventories or predefined repositories. It performs very broad discovery that is across structured, semi-structured, and unstructured data sources to identify where the sensitive data is actually residing. And by continuously scanning the enterprise environment, organizations can, I think, uncover previously unknown data stores or any other duplicate copies of sensitive information, and that data that has been moved beyond the business process or beyond the required perimeters. So once this visibility has been established, I think organizations can gain a much more accurate understanding of their data landscape. It allows them to prioritize their remediation efforts and subsequently also enforce the governance policies and reduce the overall attack that is the attack surface rather that is associated with the shadow data. So of course, discovery is only the first step, but the next challenge is ensuring that this data is obviously classified correctly or accurately. This is where minimizing the false positives, as you said, becomes extremely important. And visibility is only valuable if the classification then can be trusted. So, Ashish sir, you can take up the part of how the
Yeah.
tool is reducing false
Yes. So
positives.
I think this is a very important piece that Harsh you mentioned, and I think have been highlighted by Gaurav, that false positives, right? So so we talked about discovery a lot. Now, what happens to the classification? So when we actually scan the data, we have to build some intelligence in our scanning tool so that it, whenever it encounters some data, it understands what is it all about. Is it uh, PII data as a personal identifier information? Is it data related to some financial information as in PCI standards? Or it is related to PHI, which is health related information? Or it can also be a non-human identity information, NHI, right? Secrets and the keys as well. So, and in the agentic AI space, the NHI is as critical as a normal human identity, right? So, when our scanning tools encounters the data, it basically have to do a multi-factor analysis. It is not just based on pattern matching through a regex, but where we what we use is we use a combination of different techniques. First thing is obviously using some key algorithm like Farof's algorithm for Aadhaar, Loon's algorithm for credit card number. So these are very standard industry standard algorithms where we also validate the checksum of the data that we are reading, and then we classify it either as a credit card data or other data if the algorithm gives us a true result. But if it is not as simple as a credit card or Aadhaar, there could be even a 10-digit number which can be looking like a PAN number, and a PAN number can also
Mhm.
be can be look like a passport number. So there are multiple alphanumeric numbers and patterns that we encounter. So it is
Yes.
difficult then, and then I have seen even when we started developing, we used to get a lot of those false positives there. Maybe a telephone number is not getting recognized, but it is classified as an normal ID, or a PAN ID is getting classified as a passport number. So similar false
Practical
positives are
problems.
very,
Yeah.
very normal, because in any business landscape, there are not very well-defined data catalogs or data dictionary, right? Hardly you will see a business will go to that level of defining a glossary and a catalog of what kind of data they have. So when we do the scanning, we don't have the privilege to refer to that glossary or the data dictionary. So we have to build our own dictionary through which, and our own taxonomy. So through the different implementation and deployments we have done, we continuously enrich our own knowledge base. We enrich our AI and ML techniques, train our models, so that when we do this identification of what type of data that particular value is, we use these different techniques like dictionary and taxonomy matching, keyword matching, metadata analysis. When we say metadata analysis, we also look at different aspects. Okay, what is the column name say? What is the file name say? What is the file
Yeah.
storage name say? Right, and what kind of textual description that file name can convey as an intelligence, right? And then we also use different kind of ML techniques with respect to context based analysis, with respect to proximity based analysis, with respect to domain based analysis. So what we actually end up is build a confidence score based on different levels of iterations of our data
Okay.
classification. The plain and vanilla is obviously pattern match, which hardly gives us more than 30% confidence. But then when we
Right.
take it to multiple iterations of different levels, for example, when we go to the next level of L2, we combine a pattern match with a keyword and dictionary match, which gives us a little bit better result and confidence score of 50%. When we take it and then process along with the metadata that I mentioned, the data that we understand from the data store or the file name, it gives us some more clues. So that takes our confidence a little bit higher. But our highest level of confidence comes when we combine all of these classical ways of data classification along with the NLP based ML techniques, where we understand the business context. Because when we look into the data, our models would be able to understand whether it is coming from a banking customer, from an insurance customer, for an e-commerce customer, or a healthcare customer, right? Because ID for a patient ID and a normal employee ID would have different context, right? It is a
Yes.
simple
Yes.
ID to alphanumeric number, but we can understand whether that ID is not just employee ID, but a patient ID. And there are some PHI or health records associated with it, which is very sensitive, right? So
Yes.
these are the different even for example, a date. Now, if you have a date and then in the proximity you find and you identify there is a credit card, then you can safely kind of with a lot of confidence can say that that date could be the date of expiry, or the date of initiation of the card, right? Similarly, if you find a date beside the passport number, then you can possibly look at whether that is the date of issue or date of expiry.
Issue or explain.
Yeah,
Right.
but if you just find a date beside a random ID, which does not get
It's
classified as
difficult
either as
to
the passport
classify.
or any other credit card or any other sensitive data, then you don't consider it as sensitive, right? It can be any date. It can be a date of a particular order, date of an invoice, where standalone it does not gives you any sensitivity, or the data is not at risk. But if you see that data in proximity to a credit card or a passport number or something which is related to the personal date of birth of the customer, then you would mark it as a sensitive record. So these are the ways we enhance our classification techniques. But at the end, these are all automated ways. We have to still bring in a human in the loop. And we have a capability in our Optify solution where whatever the solution is classifying, a reviewer in the form of a business head or a data owner who is responsible for that particular data set would come and check and reclassify the data and ask us to baseline it. So they can override Optify's default classification and bring their own business rule and business knowledge, customize that, and refine it further. And once that is baselined, our system will learn from that interaction and we would remove the false positive by 100%. Right. So it is a combination of a classical technique, a AI/ML technique, and bringing a human in the loop
Human
through which
intervention.
we reduce the false positive to a large extent.